Okay, guys, we're going to do some more operations with radicals. I want to make sure that we know what we did last week, so I'm going to review that real quick, and then I'll introduce multiplying these things. So it's really not too bad. It's just kind of the same thing. So we'll start here with, let's say we got something like 2 radical 3 plus 5 radical 3. We can just add those together and call it 7 radical 3. If I had 2 radical 3 plus 3 radical 2, I can't do anything with that. It's done. This is it right here. Okay? Now, sometimes, though, we'd have something that could be reduced. So maybe something like radical 32 plus 3 radical 2. Obviously, they're not the same radical, but this guy can be reduced, right? So we can go, oh, it's 16 and 2. Remember, we look at our perfect squares, 1, 4, 9, 16, 25, 36, etc., right? And so 32 would be here. That's what we started with, was 32. And we go back until we find a perfect square that goes into it. So 16 radical 2 would be 4 radical 2, because this is 4, right? And then we bring this guy down, so plus 3 radical 2. That'd be 7 radical 2. And that's what we did last week, okay? We added up and subtracted. I didn't do any subtraction here, but it's the same idea. You add it just like it's x's and y's, just a variable, okay? But when we multiply, things get a little bit different, okay? I mean, you can multiply radicals anytime. So if I have radical 3 times radical 2, well, that's radical 6. That's pretty easy, right? What if we had like radical 10 times radical 3? That'd be radical 30. Okay, now, the thing is, when you get to this answer over here, you need to see if it can be reduced. Is there a perfect square that goes into those things? And I don't think there is on these two. You know, it's easier if you reduce first. You know, if we had reduced one of these two, if it was possible. So, you know, in this case, I can't do that. So let's try another one. Let's go radical 4 times radical 8. Okay. Well, both of those can be reduced. In fact, this is 2, right? And then this is 4 and 2. So that'd be 2 radical 2. All right, so now I have two things that are outside the radical. And that's what I multiply together. So that's 4 and radical 2. Okay? So if we had something like, what if I have radicals and things outside the radicals? So let's go 3 radical 2 times 4 radical 5. I multiply the two things that are outside the radical. 3 times 4 is 12. And then I multiply the two things that are inside the radical. 2 times 5 is 10. And we're done. That's all we have to do. That's all that we're looking for. Okay, so anytime I have something outside a radical, I multiply those two things. All right? And I just have to keep that straight. I can't multiply radicals with non-radicals. I have to keep them separate. The 12 and the 10 are in different places. Okay? So what if we have something like this? 2 times 3 radical 2 plus 4. Well, we're going to take and distribute the 2 through both of those. So the 2 times the 3 is 6, and I still got my radical 2. And the 2 times the 4 is 8. And we're done. Pretty simple. Okay? If I had like 3 times 4 plus 5 radical 2, we'd say it's 12 plus 15 radical 2. And then again, once I get here, I look to see if I have any like radicals. So this guy has a radical 2, he doesn't have one, so done. This guy has a radical 2, he doesn't have one, so I'm done. Okay, so I always want to look at the end. I might get same radicals, and I could put those together. You know, if this was 12 radical 2 plus 15 radical 2, then we'd call that 27 radical 2. 15 and 12 makes 27. Okay? Now, what if on this part there's a radical? So let's say I got radical 2 outside, and I got 3 radical 5 plus 4. Well, now I'm going to multiply my radicals. So I got 3 radical 10, right? 2 times 5 is 10 there, plus, now, there's no number here, but isn't there like a 1 there? So 1 times 4 is 4, and then radical 2. You know, I don't need the 1. I guess I could get rid of it, but It's just 4 radical 2. Now, neither of these two can be reduced, and they're not the same, so I leave it. You know, now sometimes maybe if I had like 3 radical 8 plus 4 radical 2, then I could reduce this guy. So I'd go, all right, well, that's 3, and that's radical 4 and radical 2. Okay, whoops. Just a second here. Need a 4 there. Okay, so now this guy reduces here, so that's 3 times 2. This is 2 radical 2 plus 4 radical 2. So I got 6 radical 2 then plus 4 radical 2. Because 3 times 2 is this 6. So now 6 and 4 makes 10. Okay? So sometimes this would happen. You'd get this answer and then, oh, I have to reduce that. Okay? But if they're not reducible and not the same, I just leave it just like it is. Okay? So I'll do another one of those here real quick. Let's go radical 3 times 2 radical 5 plus 3 radical 7. All right, this, so they won't be reducible here. So we'd have 2 radical 15 plus 3 radical 21. Okay? Or if we had 3 radical 2 times 4 radical 3 plus 5 radical 5. So we'd have 12 radical 6 and 15 radical 10. 3 times 4 gives me the 12. 2 times 3 gives me the 6. 3 times 5 gives me the 15. Oh, I did it wrong, didn't I? This should be a 15 here, shouldn't it? Good catch, whoever caught that. All right. So, take a look at that. There's a worksheet. Again, if you get any that are fractions, don't worry about that yet. I think there might be some fraction problems on there, so maybe something like this, or even something like this here. Don't worry about those yet. I'll put that on the assignment if they're there. We'll talk about those later, maybe. We'll see. All right. Good luck. Let me know if you have questions.